Hello students, today I am going to take a chapter from class 12. The name of the chapter is Differential Equations. Now, the definition of differential equation is an equation containing an independent variable, a dependent variable, and the derivatives of the dependent variable is called a differential equation. तो बेसिकली डिफरेंशियल इक्वेशन में एक इंडिपेंडेंट वेरिएबल होगा, एक डिपेंडेंट वेरिएबल होगा और डिफरेंशियल कोएफिशिएंट ऑफ द डिपेंडेंट वेरिएबल होगा. X generally we take it as an independent variable and Y is a dependent variable because y equals to f of x, function of x. So, and the differential coefficient means dy by dx. तो क्या क्या होना चाहिए? Y, that is dependent variable, x which is independent variable, and dy by dx which is the differential coefficient of the dependent variable y. For example, dy by dx plus 5y equal to e to the power 2x. ये है differential equation. Similarly, we can write d square y dx square minus 4 dy by dx plus 4y equal to sin 3x. This is also a differential equation. Again, dy by dx equal to x cube minus y cube by x y square minus x square y. These are all examples of differential equation. Again, x square dx plus y square dy equals to 0. This is also an example of differential equation. So, these are the forms, general form of the differential equation. Now, next is order of a differential equation. Order. Order of a differential equation. Order मतलब क्या है? The order of the highest order derivative occurring in a differential equation is called the order of the differential equation. Highest order derivative. This is first order. This is second order. Similarly, we can write d cube y dx cube, third order, and so on. Now, degree of a differential equation. डिग्री क्या होता है? जो भी ऑर्डर है उसका पावर जो होगा that is degree. Here the degree is 1. Here the degree is also 1. The power of the highest order derivative occurring in a differential equation after it is made free from radicals and fractions is called the degree of the differential equation. For example, d square y by dx square plus 7 dy by dx plus 4y equal to 0. Now, in the given equation, the highest order derivative is d square y by dx square. So, order is 2, second order, and the power of this derivative is 1. So, order 2, degree 1. Similarly, we can write this also. X d cube y dx cube to the power 2 plus dy by dx to the power 4 plus y square equal to 0. This is a differential equation. Highest order is 3 d cube y by dx cube, and the power of this highest order derivative is 2. So in this equation we write order equals to 3 and degree equals to 2. Next, I write y equals to x dy by dx plus root over 1 plus dy by dx whole square. This is not in standard form because there is a radical here. So we write y minus x dy by dx equal to root over 1 plus dy by dx whole square, squaring both sides. Y minus x dy by dx whole square equals to 1 plus dy by dx whole square. Again, expanding, we have y square minus 2xy dy by dx plus x square dy by dx whole square equal to 1 plus dy by dx whole square. Ultimately, x square minus 1 dy by dx whole square minus 2xy dy by dx plus y square minus 1 equals to 0. This is in standard form, and we see here dy by dx first order, and the power of this is 2. So we can write this is the differential equation of order 1 and degree 2. Next, another equation. Today I am discussing the form of this differential equation. What about its degree and order and degree? Next is 1 plus dy by dx whole square, and this expression to the power 3 by 2 equals to k d square y by dx square. Again we find here the power is not a positive integer, so first of all we square both sides. That means taking square of both sides. This is in standard form. We find here first order derivative, second order derivative. Usually we take the highest order derivative. So this is second order. So in this equation the order is 2 and power of this second order derivative is 2. So degree is 2. Order 2, degree 2. Another example. This is standard form. Now we have first order here, and the degree of this first order is 2. So this is an equation, a differential equation, which has order 1 and degree 2. Clear? There are some limitations also in this case. For example, if we have a term like this, e to the power dy by dx. In any differential equation, if we have this e to the power dy by dx or log dy by dx or sine dy by dx or cos dy by dx. Actually here the degree is not defined. The degree is not defined here. So what we need? A polynomial function. In a differential equation is expressed as a polynomial function. For example, dy by dx minus tan x equals to 0. This is a first order equation, and degree of this first order is 1. dy by dx whole square plus 2y equals to e to the power x. The highest order derivative is dy by dx and power or degree is 2. First order, second degree. Third is d square y by dx square equal to sine 4x plus cos 4x. Now this is a differential equation. Here order is 2 and the degree of this second order derivative is 1. So order 2, degree 1. If we write this equation, d to the power 4y dx to the power 4 plus sine d square y by dx square equals to 0. This has a term sine of d square y by dx square. Now particularly this term is not defined here. So this is not a differential equation because its degree is not defined. Again, if we have three d square y by dx square plus 5 dy by dx whole square equals to log x. In this equation we have highest order derivative d square y by dx square, that is second order, and the power of this derivative is 1, so degree is 2 and order is 2 and degree is 1. Now we come to some examples also. For example, if I write dy by dx to the power 4 plus 3y d square y by dx square equals to 0. This is the differential equation, first order, second order. So highest order is this and power of this highest order is 1. So this equation is of the order 2 and degree 1. Next, x cube d square y by dx square to the power 2 plus x dy by dx to the power 4 equals to 0. This is the differential equation. Now this is second order, this is first order. We take the highest order, so order is 2 and the power of this highest order derivative is 2, so degree is also 2. Another example, d square s by dt square to the power 2 plus ds by dt to the power 3 plus 4 equal to 0. This is the differential equation. This is second order, this is first order. We take the highest order and degree of this highest order derivative is 2. So we can say that this is a differential equation of order 2 and degree 2. Now you see how this differential equation was formed. That means the historical background of differential equation. The most interesting fact is that any natural phenomenon, anything, any type of natural phenomena can be formed in a mathematical statement, and that is differential equation. A mathematical model of any natural phenomenon comprises differential equation. Now, we have heard the name of the famous mathematician, German mathematician Leibniz. Actually, he discovered or he invented this differential equation. Some books refer to the date on which this expression was published by this great mathematician Leibniz. It was November 11, 1675. He expressed a very simple thing. Y dy integral y dy equal to y square by 2 or half y square. So he introduced two terms. This one, an enlarged s and dy. This enlarged s was called summa. This enlarged s was called summa, and this dy differentia. He was actually Leibniz, this German mathematician. He had 2 or 3 equations of tangent, and he was trying to develop the equation of the curve. On this curve, the tangents were touching like this. He got some like these equations. So he prescribed that if anybody wants to find out the equation, he has to separate the method. He has to discover the method of separation of variables. And in 1691, Leibniz was in a state to discover the method of separation of these variables. Ultimately, he discovered homogeneous differential equation, and the process of solving this homogeneous differential equation, and after that, in a very short time, he discovered the method of solving linear differential equation. अभी homogeneous differential equation, linear differential equation ये क्या है, ये बाद में हम बताएंगे. लेकिन इसके पीछे कहानी जो स्टोरी है, ये डेवलपमेंट जो है फॉर्मेशन ऑफ डिफरेंशियल इक्वेशन इज वेरी इंटरेस्टिंग. We live in a world of interrelated changing entities. The surrounding atmosphere changes with the change of time. total population changes, the velocity of a falling body changes with time, the area of a circle changes with the length of radius. From mathematical point of view, these changing entities are called variables. Some variables are independent and some variables depend on the other variables, which are called dependent variables. For example, the radius r of a circle is an independent variable, and the area capital A of the circle is a dependent variable which depends on radius r. If the independent variable is x and the dependent variable is y, then y can be written as y equals to f of x, function of x. The rate of change of a dependent variable with respect to an independent variable is called differential coefficient. d dx of y. This is independent variable and this is dependent variable. And the rate of change of this dependent variable with respect to independent variable is called, this portion is called a differential coefficient. Now this differential coefficient may be of order 1, 2, 3, etc. And if the dependent variable y depends on a single independent variable x, then the differential equation is called an ordinary differential equation. The application of differential equation is noticed in solving various problems of physical and social sciences. Now, if we want to find the relationship between the variables with their differential coefficients, now this is not our aim. We have to establish the relationship between the variables x and y within themselves. That is, the rate, if the rate of change of displacement x with respect to time t is known, then our aim is to find the displacement at any time t, not dy by dx, not dx by dt. To eliminate differential coefficient from the differential equation and to establish a relation between the variables is known as the solution of a differential equation. In nature, physical laws arise as relationship between the variables and their differential coefficients. For example, Newton's second law of motion states that the rate of change of momentum is proportional to the force applied to the object. That means P is a force and no, P is not force. We write here mv, mass into velocity, and the rate of change of this is d by dt of mv, which will be m into dv by dt. Now we can write this also as m into d square x by dt square. So we see here that the main point to study differential equation and its solution is to eliminate the differential coefficient from the equation and to establish a relation between the variables. For example, the solution of this m d square x d t square equals to p. If we establish the relation between x and t from that equation, we will get the solution of the differential equation. Now there is a historical background regarding the formation. That means how we can formulate the fact, anything which is happening in nature, how we can formulate that in the form of a differential equation. That I will tell in another episode, because it will take a time. Today I am discussing the order and degree of the differential equation, and I will give some more example regarding this. For example, x dy by dx plus 2 by dy by dx plus 9 equal to y square. Now this is not in standard form, so we multiply this equation by dy by dx. This is the standard form. And fast order, fast order, fast order, but here we have degree 2, so this is an equation having order 1 and degree 2. Next, we can write this way also. This is order 1 and degree 1. And for convenience I have squared both sides. So we find that it's not so tough. After discussing so many examples, I think you are able to form the differential equation, and you can find the order and degree of the differential equation also. Now I think I can start finding the solution of a differential equation. Y equal to A cos x minus B sin x. Now you know how to differentiate dy by dx equal to A minus sin x minus B cos x. Again, d square y by dx square equal to minus A cos x plus B sin x. D square y by dx square minus A cos x minus B sin x. D square y by dx square equal to minus y. Ultimately we have d square y by dx square plus y equals to 0. So this is the differential equation, and here we have the solution. We can write that this is a solution or the particular solution of this differential equation. This is verified. Here, this is the differential equation and this is the solution. We find that it is a dependent variable, and we find cos x, sin x independent variable, capital and capital B, two arbitrary constants. So we have separated those dependent and independent variables, and there is a relation between y and x. There is no differential coefficient here. So this equation represents a fact. Clear? It has no differential coefficient, so this is a solution of this differential equation. Clear? Next. Y equals to A e to the power 2x plus b e to the power minus x. This is number 1 and this is 2. First of all, we differentiate both sides with respect to x. So you see, this is the differential equation and that is the solution. From that term, ultimately we derive this one. There is a little bit calculation of terms here. First of all, you see I have formulated the first order and then second order. Transfer this from right to left hand side. Again writing this way, because if I take minus common here, it will be of this form. So remaining minus here, and as I have taken plus b to the power minus 2x, so I write here minus 2b to the power minus x. So ultimately by addition and subtraction we have this term here. So we can write this. Again I have taken common minus 2, this one, and this one is y. So I have derived the differential equation. Clear? take another example again. For example, y equal to ax plus b by x. We have to derive the differential equation. First, dy by dx. It is a minus b by x square. Take this x square here. Again, differentiating both sides with respect to x. This is u and this is v. Dx of constant is 0. We have to eliminate this one, a. This I can write x dy dx equals to ax minus b by x. Transfer this one to this side. So this is the solution. I mean, this is the differential equation, and this has been verified that this is the solution. Y equal to ax plus b by x. From here I have arrived here. So this is the solution, and this is the form of the differential equation. Clear? A little bit tricky. ऐसा कुछ नहीं है. प्रैक्टिस अगर करोगे तो धीरे धीरे ये जो स्टेप्स है कैसे बनाना होगा इसको, ये तुम्हारे समझ में आ जाएगा. नाउ दिस इज द फर्स्ट एपिसोड. आगे जो एपिसोड हम बनाएंगे उसमें दिखाएंगे और भी तरीके से कैसे हम शॉर्ट मेथड में शॉर्टकट स्टेप जंप करके इससे और थोड़ा सा ट्रिकी प्रॉब्लम को कैसे सॉल्व करेंगे वो हम दिखाएंगे एपिसोड्स में. क्लियर?